Welcome back. My name is Jahrul Alam. I am from Memorial University, Canada. In this lecture, I am going to give you a very simple, brief idea about finite difference approximation. I'm going to assume that we do not have any knowledge about how to do numerical method or how to do mathematical modeling, numerical simulation. Just we know how to use a computer, or we understand a little bit of mathematics, or we understand calculus. We don't have any advanced knowledge. So the objective here is to calculate the derivative of a function numerically. Suppose that I have a function u of x. If I know the function u of x is sine x, I can calculate the derivative analytically. I know the derivative of sine is cos. So if I know the derivative, if I know the function, I can calculate a derivative. So numerically, we can calculate the derivative. For example, I can look at the function of the graph typically. So numerically, I don't have the luxury of looking at the function at every point. So I don't have the computer to look at so precise details. So I will be looking at some points. For example, this is a point, and I will denote this point x by xj. So it has an index j. And a point to the right, I can denote it by xj plus 1. Another point to the left, I can denote it by xj minus 1. So the distance between the 2 points is delta x, and I'm going to assume that everywhere the distance is the same. So the point xj to the left point is also the distance is delta x. From the point xj to the right point is also the distance delta x. Now at point x, I have a value of u which I'm going to denote by uj plus 1. At point xj, I have a value u which I'm going to denote by uj, and so on. So that one would be uj minus 1. So nice thing about is that I can calculate a derivative by just simply looking at rise over run. So in order to calculate derivative here, I'm just looking at the slope. I'm looking at the slope, and approximately I'm calculating the slope. So I look at the distance between those 2 points from xj minus 1 to xj plus 1. Okay, so this is run, so which is 2 delta x. I have here delta x, I have here delta x, 2 delta x. Rise would be, I have here uj minus 1, and from that point to this point, so I have here up to here is uj minus 1. So this difference, which is the rise, which is j minus 1, j plus 1 minus uj minus 1. So the first derivative I can calculate by simply looking at uj plus 1 minus uj minus 1 divided by xj plus 1 minus xj minus 1, which is 2 delta x. Maybe I can, since I am looking at rise over run, I may not need all those 3 points. I can look at this point xj and this point xj plus 1. So I can simply see what is the rise and what is the run. So uj plus 1 minus uj divided by delta x. Or maybe I can look at here xj minus 1 at xj. And then I can see the rise over run. So the difference between those 2 points in j value would be uj minus 1 divided by the x value xj minus 1, which is delta x. So simply thinking this way, I have a data. So I look at the difference between the data points in 2 consecutive data points, where the difference between the dependent variable and difference between the independent variable, and I look at the ratio, and that is my delta u divided by delta x. So I can calculate the first derivative. Now maybe the confusing thing is that I have one formula here, another option here, another option here, and when to use what. So that perhaps you can figure out at some point, or maybe I can say you can take one of them you don't have to worry much about in most of the time. It just depends on the accuracy. We can learn it later. Now let's look at the second derivative. So for the second derivative again, I want to take the first derivative. So I will take the first derivative here. I will take the first derivative here, I will take the first derivative here, and say I will use one of those formulas to calculate the second derivative. And again, I'm not going to use the derivation. Maybe at some point in another lecture, I will be showing you how to derive that part. The second derivative would be calculated in the finite difference method by looking at those 3 points using this form of the formula. So it indicates that somehow we have to keep in mind what is the formula, and for numerical modeling or simulation part, perhaps we are going to focus much more about the phenomena, how to simulate that, rather than the derive the